And so this is the most shocking chart. It came out in 2008 from the International Energy Agency in their World Energy Outlook, November 2008. It should have been on the front page of every single newspaper, journal, book. It should have been on TV, and it just slipped by, except for the blogosphere, which really picked it up. And so what we're looking at here is energy. This is the first time that the IEA had actually gone out and said, you know what, instead of asking how much oil do we want to have, that was always how they had projected oil. They said, hey, let's add up all the oil fields in a big spreadsheet and ask the question, how much can we get out? Two things happened when they did that. The first is, you draw a line here, 2010. The first is that they made the admission that we are past what they called crude oil from currently producing fields. That's past peak conventional oil. Conventional oil, cheap oil, easy oil, not 18,000 feet down oil, not stuff that we call oil, but it's actually kerogen mixed with sand that you have to bake off under enormous pressures and environmental costs. That right there was the first admission that we had from an international agency that said we're past peak conventional oil. So that should have alone gone all over the place. The second is that they quietly notched down how much oil we're going to have in 2030 from 130 million barrels to 105. It's a 25% reduction. Just like that, as soon as they bothered to actually add the data up. This is stunning. This is a lot less oil than we thought we had just 1 year prior when they had released their outlook. And it wasn't just them, of course. An industry task force on peak oil, which is a group of 5 companies out of the UK, Richard Branson's company, Virgin being one, came up with their own bottom-up analysis and said 105, no way, 95 million barrels. That's where they thought that cap was going to be. That's the peak. Well, we're starting to triangulate. Is it 95? Is it 105? We're in there, but it's not 130. This is an immensely powerful statement that I've just made. All right, well, this came out of the Department of Energy out of the US. Glenn Sweetnam was director of this report, which is the Energy Outlook put out by the DOE. Look at this chart. 2012 was their conclusion for a peak, and that we were going to make up whatever difference we were going to make up with what they had to call unidentified projects. It's a really powerful chart that came out. Glenn Sweetnam was reassigned 2 weeks later, and you can't get a hold of him anymore. But behold the internet. It lives now, so it's everywhere. So the first thing I need you to understand about energy, when I'm saying energy, I mean oil energy, is that the quantity is an issue. Quantity, is it going to be 105 million barrels or 95? That's an important subject, but we're still not getting the second half of this story that's just as important. Just as important. So here, this is just a hypothetical chart that says, well, forget about the cost. Listen, we print money out of thin air. Is it $1 million a barrel or $1? I don't care. How much energy does it take to get energy? If you ever go out into the oil and gas business, you see these enormous steel structures that take a huge amount of embodied energy to make. So the question here we're asking with this hypothetical chart is, how much energy does it take to get energy? So how much energy do we have to put in to get some energy out? So the red part's the energy we use to get energy, and the green is what's left over, and we can do anything we want with it. If you have a sharp eye, you might notice it's not a linear relationship from one end of that to the other. Kind of trundles along and then falls off a cliff, doesn't it? Well, oh, and it crosses at 1, right? It crosses this, whoop, at 1, and you get 0, because as soon as you're spending 1 barrel to get 1 barrel, you're just keeping yourself busy. You're spinning your wheels, but you're not actually doing anything. So if somebody said there's 1 trillion barrels of oil in the center of the earth, but it's going to take 2 trillion to get it out, doesn't really matter, right? So we have to ask questions around that. When we first started going after oil, we were getting 100 to 1 returns, which is way off this chart. It goes to 50. And then by the 70s, they were 25 to 1. But look at that. It's still about the same amount of green under that from one end to the other. And that green is where we live. That's everything in this room. The temperature, the food that was out there, the fact that we got here and we're going to get home again, all lives in that green part. We care about the surplus or the net energy in this equation. That's what we really care about. And by the 90s, we were getting slightly less returns, some disagreement, 18 to 1 to 10 to 1. And oil today, you think about what they were going after with the deep water find. Might have had a return of 3 to 1, somewhere in that zone. So you can see the direction we're going. There's a trend in play here, right? Somebody says, oh, there's 3 Saudi Arabias under the Rocky Mountains, and this stuff called shale oil. Now, it's not oil, but it is shale. The energy return on that stuff, we're not sure if it's positive. Might be, but we don't know yet. Right? And so the question we have to ask is, if we're living in a world where we're at 25 to 1 returns, how different is that from living in a world where we're getting 3 to 1 returns? There's a lot less green stuff. That green stuff is the surplus energy that supports the complexity and the order of our economy. What if we wanted to live on corn-based ethanol? It has a return of about 1.5 to 1. That means that we would be trying to sneak ourselves into that world. Trust me, that's a very different world from the one that we currently live in. So it means that then the quality is important. I gave you quantity, yeah, how much? But we need to know the quality as well. We do not have a national commission at this point in time that talks about or even knows about what the energy return on an energy investment is. If we said, hey, we're going to build a high-speed, we have enough money to build a high-speed electric train or to retroactively insulate existing buildings, which should we do? I can tell you how much it'll cost. I can tell you which is more politically palatable. I can't tell you which will be better for society because I can't tell you which one has the higher return on energy invested because we don't know. It's actually a fairly complicated calculation to run. It's not as straightforward as you think. So when the workers drive across the roads to install the insulation in that building, how much of the road do you charge to that project? You know, it gets, where you draw the boundaries, it gets very rapidly complex.